Hello everyone. In this video we're going to be simplifying a radical expression. We have the square root of 2 minus root 3 divided by 3 minus root 3. I'll be presenting three methods. Let's start with the first one. For my first method, I'm going to multiply the top and the bottom by square root of 2. I'll explain why I'm doing it. So I can kind of write it like this, maybe. Okay. And then when I distribute the top, inside the radical, I'm going to get 4 minus 2 root 3. Notice that we're multiplying everything inside by 2 here. So that's why we get 4 minus 2 root 3. And that's going to help us. And the bottom, don't distribute, just leave it like that. It's better in the factored form. And now for the top, I want to take advantage of an identity. If you have something like the square root of x plus y minus 2 times the square root of x, y, now we can basically write this as the square root of x plus square root of y squared, but then the square root is going to take care of that. So if x and y are both positive and x is greater than, actually that should be a minus sign. If x is greater than y and they're both positive, all right? So it's kind of like this. Then this identity holds. In other words, we can write the square root of 4 minus 2 root 3 as square root of 3 minus square root of 1. Because we're basically looking for two numbers whose product is 3 and whose sum is 4. And those numbers are 3 and 1. You just have to use the square root symbol. So that's cool, because now we can go ahead and write this as square root of 3 minus 1, which is the square root of 1, by the way, divided by square root of 2. Now, what can I do to the expression inside the parentheses? I can take out, because square root of 3 is a common factor, sort of, right? And there's a good reason we do that, because when you take out a square root of 3 here and here, you'll end up with square root of 3 minus 1 inside the parentheses, which is very nice, of course, because then they're going to cancel out. So square root of 3 minus 1 and the square root of 3 minus 1 cancels out, leaving us with 1 in the numerator, and this becomes 1 over square root of 6. So that should be the answer, but let's go ahead and rationalize the denominator. Multiply by root 6 over root 6. That's going to give you the square root of 6 divided by 6 as the answer. All right, let's go ahead and take a look at the second method. First method basically took advantage of an identity for radicals of this form, and then we just simplified it that way. For the second method, I'm going to go ahead, let me rewrite the original expression. This is what we're trying to simplify. I'm going to set this equal to a variable like a. It doesn't have to be capital, it could be lowercase, it could be anything you want. Now, I'm going to go ahead and square both sides. Now, squaring both sides is actually very helpful here, because that allows you to get rid of some of the radicals. So the top is going to be, from here, a squared equals 2 minus root 3. Obviously, the radical outside, the radical that's outside disappears. And at the bottom, you're going to get 3 minus root 3 squared. And we're going to simplify that now. Let's go ahead and expand it. If you square a minus b, you know the drill, right? Hopefully. A squared plus b squared minus 2 times a times b. Or can I just write it as 6 root 3? Allow me to do this. Shouldn't be too hard. And now 9 plus 3 can be added. And that's going to give me 12 minus 6 root 3. And now, notice that I can factor something out of the denominator. And what is that? That's the common factor. The greatest common factor happens to be 6. So I can go ahead and take out a 6. And inside the parentheses, I get 2 minus root 3. Which is again nice. Of course, this should work, right? Everything cancels out pretty much, like 2 minus root 3. And we end up with 1 over 6. But that's not the answer, because 1 over 6, as you can see here, is equal to a squared. So we can write this as a squared equals 1 over 6. And a is what I'm trying to find. So from here, a is equal to 1 over root 6 or negative 1 over root 6. But one thing to keep in mind, our original expression is always positive. Why? because 2 is greater than root 3. Even if it wasn't, then we wouldn't have a real number if it wasn't. Anyways, so the top is positive, and 3 minus root 3 is also positive because 3 is greater than root 3, obviously. So we have a positive expression, so the answer should be positive. So we don't have to worry about the answer being negative. We're just going to discard it. So a is equal to 1 over root 6, but let's go ahead and rationalize the denominator, and we're going to get root 6 over 6 as before. I hope that makes sense. Let me kind of recap what we did. We set our expression equal to a, and then we squared both sides. We got this expression. The bottom, we had to expand a minus b quantity squared, and then we added like terms, and then we factored. 2 minus root 3 cancels out. We end up with 1 over 6, and that means we have to square root both sides and take the positive solution because our expression is positive, and the answer is root 6 over 6. Let's go ahead and take a look at the third method. Let's see how that plays out. The third method is taking advantage of something else. And all these methods are, I think, fairly different, I would say. Let me know if you disagree, because they're not really using the same ideas. Well, sort of. So here's my third method. I want to rationalize the denominator directly. I don't care if there's a complex radical in the numerator. Let's go ahead and get rid of the radical at the bottom at least. So we have 3 minus root 3, so we should multiply by 3 plus root 3 over the same thing, right? And then let's go ahead and distribute. Now, here's the tricky part. You kind of have to distribute something that is not a radical by a radical, but that's not an issue. So here's what we're going to do. I'm going to write this 3 plus root 3 as square root of 3 plus root 3 squared, so that they're going to be under the same radical. And the bottom is just going to be 9 minus 3, which is equal to 6, right? So now, let's go ahead and expand the second radical first. The second radical is going to be 3 squared plus root 3 squared, which is 9 plus 3. That is going to be 12, right? And then plus 2ab, remember a plus b quantity squared, is going to be 6 root 3. And at the bottom, you're just going to have a 6. I know it's tempting to take out a 6 and cancel out, but that's not a 6. Actually, that's the square root of 6. So let's go ahead and see what we can do from here. I can take out a 6 here. So inside the radical, I'm going to be getting 6 times that. And then 2 plus root 3. And now I can take out a square root of 6 here and then take care of these two radicals. These two radicals, this one and this one under the radical, they can be multiplied. And guess what? They're just going to form a difference of 2 squares. A squared minus b squared, that's going to give you 1, right? So 2 plus root 3 multiplied by 2 minus root 3 is 2 squared minus root 3 squared, which is 4 minus 3, and that's equal to 1. So this times this equals 1. You end up with root 6 over 6, which is the answer. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.